Hello Year 9. Today we are using relative frequencies to estimate probabilities. So we have some terms at the top here that you need to be familiar with. The first one is relative frequency. Now relative frequency is a lot like probability. All it is how often a score occurs divided by the total number of outcomes. We've been doing that for probability, haven't we? The next word is experimental probability. This is how often a score occurs divided by the total number of outcomes when it is done in an experiment. So it's not theoretically how often something should happen, but as an experiment, in your experiment, how many times it occurs. So there's a formula here for you. Experimental probability is the number of times the outcome occurs over the total number of trials. Long run proportion is the experimental probability after a large number of trials. So you can imagine if you were rolling a dice, it might be quite possible to get 1 6 or 2 6s, or maybe even if you're very lucky, 3 6s in a row. But the more times that you do that in the long run, if you keep rolling that dice and keep rolling that dice, the more times that you do it, it should get closer to a 1 in 6 chance of rolling a 6 on a dice. And that's called a long run proportion. The expected value, or the expected number of occurrences, is how often an event is expected to occur from a certain number of trials. The answer is a theoretical answer. It may not happen if you conduct the experiment, but the more times that you do conduct the experiment, the closer we should get to the expected value. So this formula here is a very important one. Expected value. To find the expected value, you will multiply the probability by the number of trials. So always look out for that word, expected value, in your questions. So let's jump into our examples. Example number 1. Consider the following data which represents where students from a school went on their end of year excursion. So this is a school that obviously has a primary, because we have female primary students, male primary students, and we also have a high school, female secondary and male secondary. Now there's 4 locations that they might be going for their excursion. They might go to Avoca, Terrigal, Gosford or Sydney. So the first thing we're asked to do is to complete the totals for the table above. So to do that, I need to add down this column to find the total at the bottom. So if you grab your calculator, the first column will be 13 plus 14 plus 18 plus 26. So that's a total of 71. Then add the second column, 15 plus 19 plus 32 plus 18. So 84. The third column, 21 plus 14 plus 8 plus 19 is 62. And 16 plus 26 plus 10 plus 31 makes 83 for the last one. Now, to get the totals on the end here, we need to add across the rows to find those. This will be the total number of people that go to Avoca. So it's 13 plus 15 plus 21 plus 16. So there's 65 people who go to Avoca. Then the next one. So a lot of adding in here. $73, then $68, and one more row, 26, 18, 19, and 31 makes 94. To get that last remaining box, we have a choice. We can either add down this column or across the row. You should get the same total either way. So I'm going to go down that column there. So 65 plus 73 plus 68 plus 94 is 300. Okay, you can double check that by going across the row. If you're ever in your test and you just want to make sure that you've gotten everything correctly, got everything done correct, you just add them both up and you get the same thing. Okay, so then part B says, find the relative frequency of female secondary students. So how many female secondary students are there out of a total? So female secondary students, there is 62 out of a total of 300. So we write that like we would a probability. There was 62 out of 300. And we can simplify that on our calculator. So it's a 31 out of 150. Okay, part C, find the relative frequency of secondary students. So this means we only want to talk about the secondary students. So if I get rid of that one and that one, no, can't really undo my highlighting there. I'll just do it in a different color instead. So secondary students means we only want to talk about these two totals here. So altogether, we have 62 plus 83. So there is 145 secondary students. Now, we want to know how many of those secondary students visit Terrigal and Sydney. So, Terrigal, there was 14 girls that visited Terrigal, 19 girls that visited Sydney, 26 boys that went to Terrigal, and 31 boys that went to Sydney. So all those ones that I've highlighted there in green, I need to add those up. So let's do that. We have 14 plus 26 plus 19 plus 31. So that is 90 students that were in high school that visited Terrigal and Sydney. Now that is out of a total of the secondary students. There was 145 secondary students. So that's what I need to put on the bottom. So that you need to read the questions carefully to know that one, to work out what to put on the bottom. It says of the secondary students, which means I only want to know the total of the secondary students and then how many students went to Terrigal and Sydney from there. So let's just check to see if we can simplify that. 90 over 145 makes 18 out of 29. Okay, on the next page, question 2. A coin is flipped 50 times. How many tails are expected? Okay, so there's that word expected. Remember, up here at the top of the page, the expected value is equal to the probability times the number of trials. So if I want to find the expected value, I need the probability of getting a tail times by the number of times that I do it. Okay, so that's going to be equal to any coin that you flip, there is one tail out of 2. So it's a half. You have a probability of a half of getting a tail when you flip a coin. I times that by the number of times that I do the trial, which is 50 times. So half times by 50 is, now you can type that into your calculator if you need to. So you go half times by 50, and that is equal to 25 times. Okay, now it does say here in brackets with the capital letters there, show working. So on your test, I don't just want to see you write 25 times down there. You go, oh, it's going to be half the time. Let's just put 25 down there. I want to see that you know that you're timesing the probability by the number of trials. I want to see that working out. So let's do it again for part B. A dice is rolled 72 times. how many sixes are expected. So there's that lovely word expected again, which tells us that we want to use that formula. So we want the probability of rolling a 6. So on a normal dice, there's 1 6 out of 6 choices. So it's a probability of 1 out of 6. We times that by the number of trials, which this time is 72. So it's the probability times number of trials. Probability is 1 out of 6 times the 72 means 12. We would expect to get 12 sixes if we rolled the dice 72 times. Question 3. A box contains an unknown number of coloured balls. A ball is drawn from the box and then replaced. The procedure is repeated 100 times and the colour of the ball drawn is recorded each time. 35 blue balls were recorded as being drawn out. Okay, so that 35 blue, that's important, and that we did the experiment 100 times is also important. Find the experimental probability for the number of blue balls. So this is just normal probability. We found from drawing them out, we got 35 blue balls out of the 100 times that we did it. So type that in your calculator to simplify the fraction. 35 over 100 is 7 out of 20. Part B, find the expected number. There's that word again, expected. Find the expected number of blue balls if the box contains 600 balls in total. So remember, to find the expected value, you take the probability. I'm going to take the simplified one, the 7 out of 20, and you multiply that by the total number, which was 600. So 7 out of 20 times by 600 means there was 210 blue balls in that box based on the experiment that was conducted. Okay, that is it for my questions. Here is your ones down here in exercise 10E.